A polygon is a two-dimensional figure whose sides are all straight lines. The sides end at endpoints, and they are closed. They make an inside and an outside. These shapes are all polygons. All the sides end at endpoints, and they create an inside and an outside. Even weird looking shapes like this are polygons because all the sides are straight, all the sides end at endpoints, and there is an inside and an outside. These shapes are not polygons. These first two are not polygons because they have round sides. The circle just has one round side. This shape has a curved side. In this example, this is not a polygon because this endpoint does not end at this endpoint. If I took this endpoint and drug it down here and made a triangle, I'd have a polygon. But the way it sits, this is not a polygon. And this last example is not a polygon because it has too many interiors. If I cut off just this bottom triangle, I'd have a polygon, or I cut off the top triangle, I'd have a polygon, but together it creates too many interiors. Polygons can be classified many ways. The first way we're going to classify polygons is by the number of sides. If a polygon has 3 sides, it's called a triangle. If a polygon has 4 sides, it is a quadrilateral. If a polygon has 5 sides, it's a pentagon. 6 sides is a hexagon. 7 sides, heptagon. 8 sides, octagon. 9 sides, nonagon. And 10 sides, decagon. You're going to have to memorize the names for these polygons, from triangle to decagon. When a polygon has more than 10 sides, we name it with the number of sides / gon. So an 11-sided polygon is called an 11gon. A 12-sided polygon is called a 12gon. Each of these polygons is a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 gon. There is a name for a 17 gon, but you're not going to have to know it for this class. We're just going to call anything past 10 that number / gon. In general, if we don't know the number of sides, we're going to say the number of sides is n, so we're just going to call it an n-gon. An n-gon is a polygon with n number of sides. N is going to be our variable. We don't know how big n is. It could be a number of numbers. There are certain properties that polygons have that also help us classify the polygons. All of these polygons have a certain characteristic. They're all dented in. When a polygon is dented in, it is known as concave. A polygon that is concave has one angle that measures more than 180 degrees. These are all concave polygons. If we look, here's my angle that measures more than 180 degrees. Here's the angle that's more than 180 degrees. This shape actually has two angles that are more than 180 degrees, and this one has one. These polygons are all not concave. The opposite of concave is called convex. All of the angles in these polygons have measures that are less than 180 degrees. To help you remember the difference between concave and convex, think of caved in, dented in. All of these polygons have a side that has been dented in or caved in. The opposite of concave is convex. Another way to classify polygons. All of these polygons have sides that are the same and angles that are the same. All the sides are congruent to each other. All the angles are congruent to each other. When a polygon has all the sides congruent and all the angles congruent, it is known as regular. All of these polygons are regular. These polygons are not regular. The name for non-regular polygons, irregular. Now be careful. An irregular polygon can have all the angles congruent, like this rectangle. But the sides of a rectangle are not all congruent to each other, so this rectangle is irregular. We can have a polygon where all the sides are the same length, but the angles are not the same length. This pentagon looks like it should be regular because all the sides are the same length. But if we look at the angles, I have two right angles, two angles that are obtuse, and one acute angle. This is not a regular pentagon. This is the regular pentagon. Another way to classify a polygon is whether or not it has line symmetry. Another word for line symmetry is reflection symmetry. Line symmetry and reflection symmetry just mean that we can take our polygon, fold it in half, and both sides will be exactly the same. The folding line is called the line of symmetry. All of these polygons all have line symmetry. The line of symmetry is a dashed line. Notice that some of these polygons have more than one line of symmetry. These polygons do not have line symmetry. We don't have a name for polygons that don't have line symmetry. They're just not symmetric. Be careful. A shape like this last one looks like it has line symmetry. If I connect from this point to this point, these two halves are congruent to each other, but I don't have reflection or line symmetry. If I folded this shape in half on this line, this side would not match up exactly onto this side. This shape does not have line symmetry. It actually has rotational symmetry. If you remember, we talked about rotational symmetry in Chapter 1. If I rotate this shape around, it will line back up with itself, so it looks like I have line symmetry, but it's actually rotational symmetry.